Yeah, I don't think that's true. I think everything's due tomorrow. Try not to get too behind. Stop, stop the video. There we go. Okay, sorry, I was doing too much for Zoom, I think, and it froze on me. So anyway, get the idea of what this is this leaf rose is. Okay. So let's go back to okay. So let's find the area of one loop of the four-leafed rows r equals cosine 2 theta. And we saw what this kind of looked like. Okay, it looks like this. I'll just draw it for you real quick. We've got 1, 1, 1, and 1. Okay, so we start here at theta equals 0. Okay, and we start curving, and we curve toward the origin. Okay, now why is that? Why is this? Well, let's just do a little bit. Let's see what happens here. I'd like to work with some cosines. So cosine of 2 theta. I'd like to work with some thetas that will make cosine nice. What the heck? Stop. Okay, and so this is going to be 2 theta, right? So what thetas are going to be nice when I plug into cosine? Well, that's going to be like 0, pi over 2, okay, pi, 3 pi over 2, right? And so on and so forth. Okay, maybe 2 pi, right? So what thetas am I going to actually be working with? Well, I just got to cut these guys in half. So 0 cut in half is 0, pi over 4. Pi over 2 cut in half is pi over 4. This is pi over 2. This is 3 pi over 4. And we're going to cut it down to pi. So you can see this thing is going to have a period of pi instead of a period of 2 pi, right? So, okay, whereas cosine has a period of 2 pi, this thing's going to have a period of pi because we're going through the same cycles, just half the radians. So cosine of 2 theta, okay, well that's just the cosine of 0 is 1, right? Cosine of pi over 2 at pi over 4. So again, I'm going to put my r theta here. Okay, so this was at r was 1, 0. Okay, for pi over 4, this is going to be the cosine of pi over 2, which is 0. Okay, and so this is going to be 0 pi over 4. Okay, 0 pi over 4. Okay, and so that's why we start here at 1, 0, but then we're at 0 at pi over 4. So let me get an auxiliary line here going. This is my pi over 4 line, right? That's my pi over 4 line. Okay, and at pi over 4, at the angle theta, we're at the angle theta of pi over 4, we're at 0. So we kind of start off, but then as we hit pi over 4, we hit this 0 mark, right? Okay, and Then where do we go from there? Well, at pi, well, what's pi? Pi, the cosine of pi, right, at pi over 2, okay, the cosine of pi is, well, it's -1, right? So -1, go back to black. Okay, -1, okay, and then, so this is going to be -1 pi over 2, okay. So where's pi over 2? Pi over 2 is this direction, right? That's pi over 2, but we're at -1. Well, where's -1? It's down instead of up, right? Negative r is going the opposite direction. So we're actually curving like this, like so. Actually, I don't want to do that in black. I want to do that in red. Okay, we're curving like this, okay? And then we go up like so. So this is the trajectory of the thing. It goes like this, and then it, not curving too well. Okay, so like so, goes out like this, then it goes off like this, and it goes up like this, and then it goes down like this. Okay, and it cycles through. Okay, and so and as theta goes from 0 to 2 pi, it creates all 4 of these petals, but we only want these petals. Okay, we only want one of the petals. Okay, so I don't want you either. Okay, so I know that we go back to 0, okay, at pi over 4. So this is pi over 4. I get this top arc here. Maybe I'll put that in black. I get this top arc by going from 0 to pi over 4. From 0 to pi over 4, I get this top arc, which is in black. The bottom arc, okay, which I'm going to put in blue, okay, the bottom arc here, okay, is actually from -pi over 4 to 0. This is -pi over 4, okay, -pi over 4, okay, or you could think of it as 7 pi over 4 to 0. Okay, if I were to go out here to 7 pi over 4, right, 7 pi over 4, right, okay, I would be back at 0. Okay, and then at 2 pi, which is the same thing as 0, I'd be back at 1. So 7 pi over 4 would be 7 pi over 2, which every pi over 2 is a 0. Okay, and so we'd be at 0, 7 pi over 4. And you'll see that as this is the 7 pi over 4 or -pi over 4. I could think of it as -pi over 4 as well. So when I set up my integral, I'm actually going to go from -pi over 4. I'm going to go backwards. I'm going to go from -pi over 4, okay, to pi over 4 of 1/2 times r squared d theta. Well, what's r? In this case, r is cosine 2 theta. So this is cosine 2 theta squared d theta. Okay, and that's the area of one of these petals. If I wanted to find all 4 petals, I just multiply this area by 4 because of the symmetry involved. Okay, but we just want to find one of the petals. Okay, what's the area of one of the petals here? Okay, so let's do this integration. Okay, so I'm going to let u equal 2 theta. Du is equal to 2 d theta, or du over 2 is equal to d theta. Okay, so I'm going to pull the 1/2 out, -pi over 4 to pi over 4. Okay. Pull the 1/2 out in front. I get cosine of u squared, okay, or cosine squared u. I can rewrite it without the parentheses, either way. Cosine squared u, okay, du over 2. So I could really pull this 1/2, the d over 2 out in front and make it a 1/4, right? So 1/4 integral of -pi over 4 to pi over 4 of cosine squared. Well, how do we deal with a cosine squared? We use a half angle identity, and we say that, oh, okay, this is going to be 1/2 plus 1/2 cosine 2u du. Okay, 2u. Okay, and if I really wanted to, I could do another u sub on this. If I really want to, I could break this up. This is 1/4 times the integral from negative pi over 4 to pi over 4 of 1/2 du, okay, plus, okay, although, it's not, nope, I'm wrong. It is not this. I didn't change my limits of integration, sorry.
I was about to say.
Yeah, I did not change my limits of integration. My limits of integration are with regard to theta, and u is equal to 2 times theta. So if I did pi over 4, this is 2 times pi over 4, which is pi over 2, right? So this is going to be from pi over 2 to negative pi over 2 now. Okay, so this is pi over 2 to negative pi over 2. So negative pi over 2 to pi over 2. Okay, plus the integral from negative pi over 2 to pi over 2 of 1/2, okay, 1/2 of cosine 2u du. And if I want to do another u sub, I could, if I really wanted to. I could say, oh, w here is equal to 2u, so dw is equal to 2 du, so dw over 2 is equal to du. We just get a lot of these 2's here on the denominator. So we could say, 1/4, okay, okay, 1/4 of, let's integrate this guy. This guy's just 1/2 u from pi over 2 to negative pi over 2. Pi over 2 to negative pi over 2. Okay, plus, okay, let's do our w substitution here. This is w. Okay, this is going to be 1/2 times the integral. We're going to have to change our limits of integration one more time. Multiply both pi over 2 and negative pi over 2 by 2, right? So again, that just gets rid of the dividing by 2. So this is just pi over negative pi, okay? And then this becomes cosine of w dw over 2. Oh, okay. Okay. So now I can pull that out, that 2 out in front, and I'm going to make this a 1/4. Okay. Let's make that a 1/4, and we'll get rid of the dw over 2. Okay. But what is the integral of cosine? Isn't that just sine? So this is sine from pi to negative pi times 1/4, right? And then 1/4 of that whole thing. Okay, but what is the sine of, what's the sine of pi? Well, the sine of pi minus the sine of negative pi. Well, the sine of pi and the sine of negative pi are the same thing. They're both 0. Okay, this goes to 0, and that goes to 0. And so what's 1/4 times 0? Well, that's just 0. 1/4. So this is plus 0. This whole thing goes to 0. Okay, plus 0. Oh, okay, that's kind of cool. So now what we have to do is evaluate the front part here. So this is 1/2 times pi over 2 minus 1/2 times negative pi over 2. Oh, okay. So this is 1/4 times pi over 4 plus pi over 4. Well, what's pi over 4 plus pi over 4? It's 2 pi over 4 pi over 2. So this is 1/4 times pi over 2, which is pi over 8. Okay, which is the area. That's the sector area of this guy. Sector area. Okay, let's do another one here. Okay. Okay, number 2. I'm gonna go back to the red pen. Okay, number 2, find the area of the region that lies inside the circle r equals 3 sine of theta, and outside the cardioid the cardioid r equals 1 plus sine theta. Okay. So again, let's go to Desmos, see what this looks like real quick. Hopefully the system again. Okay, I'm just not going to write on Desmos because that seemed to really mess things up. Okay, so we want r equals 3 sine theta. What does that guy look like? Okay, r equals 3 sine of theta. Okay, that's a circle. Look at that. That's a circle. Okay. Looks like a circle of radius 1.5. Okay, if I were to zoom in on that. Okay. Center is at 0, 1.5. Okay. Okay, and then what about the next one? The other one is r equals 1 plus sine theta. That's our cardioid that we've been working with. R equals 1 plus sine of theta. Okay, so we want the area that's inside the circle but outside the cardioid. So we want this top area here. Again, I wish I could draw on this, but maybe I'll just sketch this out real quick. Okay, we had our circle here, and then we had our cardioid. Okay, we had our cardioid like so. Okay, and so what's the area we're wanting? We're wanting this area here. Okay, so what I have to do is I have to find out the angle of intersection for each of these. At what angle do these things intersect? Okay, that's a really bad circle. Let me try to draw the circle again. A little bit better. Maybe it's not the circle that's bad. Maybe it's just the cardioid that's bad. I should really be getting some symmetry here, but I'm not getting the symmetries. So this is a circle. Oops. Circle. There we go. Okay, and then this is going to be my cardioid. There we go. Do that to me. Heck, stop. Okay. So I've got this guy, and the area is inside here that I'm looking for. And I just want to get my points of intersection here. Okay, for what angle? Oh my gosh, why when I erase does it just take away everything? Do not take away everything here. Okay, do not take away everything. Okay, I just want the points of intersection. Boom. Okay, there's the circle. And we want the area outside the cardioid, but inside the circle. So we know that the circle is on top. Top is the circle, which is r equals 3 what is it, sine? It was sine theta, right? 3 sine theta. Okay, and the bottom function is r equals 1 plus sine theta. Okay. Okay, so what I want to do in this case is I want to first find the points of intersection. Then I want to take the area of the circle minus the area of the cardioid between, okay, between the regions of the angle, the angular region, between that angular region. So first I need to find out, well, where do these intersect, right? Where does 3 sine theta equal 1 plus sine theta? Where do these graphs intersect? For what values of theta do they intersect? And that'll give me my limits of integration. Okay, so let's subtract off a sine theta here. I get 2 sine theta is equal to 1. Okay, and I get sine theta is equal to 1/2. Well, what angles will give me a sine of 1/2? Well, that's pi over 6 and 5 pi over 6. It's only 2 angles that will give me a sine value of 1/2, and that is pi over 6 and 5 pi over 6. Okay, and so I'm going to take the area of the circle minus the area of the cardioid. Okay, the area of the circle minus the area of the cardioid to get this. So what's the area? Well, it was 1/2 times the integral, right, from a to b, pi over 6 to 5 pi over 6 of the circle, the function squared d theta, right? So the circle is 3 sine theta squared d theta minus 1/2 times pi over 6 to 5 pi over 6 of 1 plus sine theta squared d theta. Okay, so what I'm going to do is I'm going to combine this all into one integral in a minute. So this is 1/2. This is going to be pi over 6, 5 pi over 6. This is going to be 9 sine squared theta minus, okay, minus. Now I would have factored out the 1/2 and put it in front here, so I don't have to deal with that 1/2. And I'm gonna square this out. This is minus 1 plus 2 sine theta plus sine squared theta, okay, d theta. Okay, so this is equal to 1/2 times our integrated from pi over 6 to 5 pi over 6. Okay, and does it make sense that we would go from pi over 6 to 5 pi over 6? Yes, it does, because look at where these intersections are. This is pi over 6 to 5 pi over 6. Yeah, that makes sense, that they intersect. Those two graphs intersect between pi over 6 and 5 pi over 6. Oh, okay, cool. Okay, so this is going to be, I'm going to distribute my minus sign here. This is 9 sine squared theta minus 1 minus 2 sine theta times, or minus sine squared theta d theta. Okay, so I'm going to combine the 9 sine squared theta and the minus sine squared theta. So this is 1/2 pi over 6 to 5 pi over 6 of 8 sine squared theta, right? So those combine, minus 2 sine theta minus 1. Okay. Okay, and then what I'm going to do is I'm going to actually distribute the 1/2 back in. Okay, just to get rid of that 1/2. So I get pi over 6 to 5 pi over 6, because I can divide 8 by 1/2 and 2 by 1/2. I'm going to get 4 sine squared theta minus sine theta minus 1/2. Okay, so now I'm going to just integrate these individually. The first one, I have to use the double angle formula on. So this is going to be 4 times 1/2 minus 1/2 cosine 2 theta minus sine theta minus 1/2. Okay. So distributing, we would get 2 minus 2 cosine 2 theta minus sine theta minus 1/2. 2 minus 1/2 is 3/2. We get 3/2 minus 2 cosine 2 theta minus sine theta. Okay, and I could integrate this, okay, each of these individually. I would do a u sub on this one, although if you remember, what is the outcome of doing a u sub here? What's the outcome of letting u equal 2 theta? Don't we end up just dividing by 2, right, for our du's? Right, so the outcome here would be that I would end up dividing by 2. And so I'm going to rewrite this as minus, okay, minus, well, well, let's just do the u sub anyway. Just know that this 2 is going to cancel because we're going to get a du over 2. Okay, and then when we integrate our u, well, let's just do it. Let's just do it symbolically here, real quick. Okay, u is equal to 2 theta, du is equal to 2 I can't even talk. 2 d theta, divide by 2. Okay, and we get du over 2 equals d theta, right? So I would get minus 2 times the cosine of u, du over 2. So what happens? Well, these two cancel each other out.